Yes, am I audible properly?
Yes, sir.
Yes, good morning to one and all. Welcome back to online virtual uh, lab. So, dear students, in the previous class, we have been discussed about two experiments. The aim of the two experiments will be the same. We need to determine the hardness value of the given sample. That one method or one way, or that is one way through Rockwell we need to determine the hardness value of the given sample, and the second method or second way we will choose the vinyl hardness machine to determine the hardness value of the given sample, right? The beginning class only I told all the three experiments are very important. We have to have that practice and we have to have that knowledge about all the three experiments, because all the three experiments are having their own perspective to determine the hardness value of the given sample. Some materials are suitable for the vinyl test and some materials are suitable for the Rockwell test, right? In that sense, we need, depending upon the materials, we have to choose or we have to select the machines out of three machines. Now today our planning is to conduct the Vickers hardness test. How to determine the hardness value of a given sample by using the Vickers machine. And one thing, and second thing, how this Vickers test is differ from the other two tests. What will be the working principle of this Vickers test? How it's work uh, from others, some other two, how it differ from other two experiments. Now we will discuss the working principle of this Vickers hardness test and what kind of the materials we can able to choose for conducting the Vickers test. And what are the materials are there, those are suitable for the Vickers tests, and Vickers test is suitable for what kind of the materials. All these things which we can able to discuss through this virtual lab, right? So now I will start from the theory and aim also. I will tell you that aim is the to determine the hardness value of the given sample by using the Vickers hardness testing machine, right? Now theory, already we have been gone through the theory. The Vickers is also one of the hardness test or one of the method to determine the hardness value of the given sample. The name scientist Vickers is developed this uh, uh, at or sometimes we can call it as a laboratory name is on Vickers, so that the peoples are involving and activities at the invention about this Vickers or involving in the Vickers laboratory, hence the name becomes it is a Vickers testing machine. Theory we don't want much. Now I will show you this machine how it is look like. This machine also look like as similar as Rockwell and Brinell test. And one thing you should keep it in your mind, Brinell and Rockwell, these two experiments we can perform in same machine. We will not take a different machine from for Brinell test. May sometimes we can able to perform the Brinell test in Rockwell machine only, but only we need to take the electronic microscope separately, or sometimes that electronic microscope also inbuilt at the head of the machine also. Okay, that type of the machine is also available, and simple machines as we can see the Rockwell test, that test machine, that machine is also available, right? But we need to perform the Brinell test. So the Vickers machine, you have a Vickers machine, that's enough for conducting the Brinell test also. But however, we need a separate microscope, right? Because the principle of this Brinell is to determine the indentation diameter. We need to determine the small d. Small d means diameter of the indentation, because that Brinell given a formula, so we need to simplify that formula. Thereafter we will get the values. That value we can call it as a Brinell number. So that formula, already the known values are there in that formula. formula that P is applied load and capital D is there and small d is there, and well as well phi value is there. Phi value we know, everybody all we all know the value of the phi, and capital D is the indenter of diameter of the indenter, and small d is the diameter of indentation. So hence we need to determine the diameter of the indentation. For that we need to take the separate electronic microscope. So this is the thing which we discussed in a vinyl harness testing machine. Now we are today we are looking to the Rockwell harness testing machine. This also look like as similar as vinyl and Rockwell test, but here yes we can able to see this is the uh, here there is an electronic microscope, and here there will be the indenter holder, and this is the anvil, this is the anvil lever, and here the load lever is there. Here there is the load setter or load unit is there. Everything will be the same. This machine also look like as similar to the Rockwell test or Rockwell testing machine, right? Now the one more important thing in this Rockwell test, here we are using the diamond shaped indenter that will be sometimes fixed into the machine. Most of the time this diamond shaped indenter is fixed into the machine itself, right? Most of the times. Some special cases only we need to change the diamond indenter, or we are changing the diamond, we are replacing the diamond indenter by diamond indenter, but only the thing is change the angle between the angle between the faces or apex angle. So angle between these two faces will be sometimes changed, since we can call it is a apex angle. So apex angle here, one example here we are taking the apex angle is 136 degree. So similarly the sometimes there may be a change, there may be the chances of changes this apex angle. At that situation only we can able to replace the old one to the so new one, right? At that situation only we can able to choose the or select the or replace the indenter. Most of the cases the diamond type of the indenter which we can use for the Rockwell harness test, and that will be fixed into the machine, right? Now here we can able to see this is the diamond indenter. So this is the diamond or rhombus type is there. There are there are two opposite faces, one and two. These are the, you can call them as opposite faces. In here we need to look into that angle. This angle will be very important, keep it in your mind. In particular one applications we are using this type of the indenter. So this has 136 apex angle, right? Sometimes may this indenter will be changed by changing the angle, right? So once this diamond indenter impress over the workpiece, here also we need to determine the impression, diameter of the impression or diameter of the indentation, as similar as Brinell test. In Brinell also we need to determine the penetration, diameter of the penetration. In this case also we need to determine the diameter of the indentation. But in Brinell cases that penetrator which is in the form of circular, but here penetrator which is in the form of diamond. If it is a ball or a spherical shape, we can able to determine their diameter easily. Yes, na? If it is in a circular shape, we can easily we will get the diameter of that penetration. That will be the small d. Then we can use that small d to for the simplification of formula. But in the case of this Vickers, here we are not using the ball shaped indenter or penetrator. Now here we are using the diamond shaped penetrator, hence the print will be like this over the material. Definitely that you can look into this diamond indenter in a front view, it's look, or in a top view it is look like a square, right? If you can take that into the front view or in top view, this rhombus, that point, that edge, if you want to look into that edge of that indenter in the front view or else in the top view, well, from the top it look like a square. Hence we need to determine the so uh, diagonal length of the square. So diagonal length of the square means this from right top corner to left bottom, or from this way or this way. So this is the diagonal length of the square. Definitely you know very well about the diagonal length of the square. Why it is square? Because it is a rhombus diamond shape. That tip will be look like whenever we are looking into the front view or top view, it is look like a square. Hence the square tip will be penetrate over the workpiece. Hence we will get the square shape penetration over the workpiece. Now we need to determine the diameter of this rhombus or square. Hence this is not a circular, we cannot. So if it is a circular we can able to determine easily, but if it is a square then we need to take the overall diameter. Hence we can able to take this diagonal length of that square. So d1, that will be considered one diagonal length will be, we can call it as a d1, other we can call it as a d2 and d1. Now later we can take the average of d1 and d2. Hence we will get the small d1 plus d2, the average of d1 and d2, that will be the small d. Small d in the sense indentation of penetration, which is in the form of diamond or square. Hope you understand. The next case, how we need to determine these diagonal length. How we need to determine the d1 and d2. This is a very important thing. While we are going to the simulation, I will tell you how to determine the diagonal length. Only we can able to understand through the simulation. At that time I will explain you how to determine the each diagonal lengths. Right, now I will finish this theory parts. This is unnecessary, we will not go into these things. Now this is the very important, some examples of so Vickers hardness test. What are the materials? That's what I told you now in the beginning only. What kind of materials we can be able to perform in this Vickers hardness test machine, or which are the materials are mostly suitable for getting the hardness value through the Vickers hardness test. These are the materials the most commonly which we can able to determine the hardness value of the these kinds of the materials through the Vickers test machine. Most commonly we are using this is the grade 1316. Yeah, this is the grade number of this one kind of the stainless steel. Now so if you want to determine their hardness value, so hence we can take the Vickers hardness test. Here we are getting that value is around about 140 HV. Sometimes they are mentioning scale also here, C, A, B or C. May sometimes they are not mentioning. So that is very important. Here HV means Vickers hardness number is 140. 30 is what? Anybody can tell me what is 30? Am I audible? Hello? 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 Am I audible? Hello? Raghavendra, Mallappa. Am I audible?
Yes, sir.
So just no, you can tell it. Otherwise, you can say no. So this is the value of 30. 30, it shows what? What it indicates? Don't know. Okay, let it be, no problem. So 30 is the study time or dwell time. So yesterday only we have discussed we need to wait for some period of time, or some period of time means we need to wait for 10 minutes, 15 minutes, 20 minutes and 30 minutes, because we need to give the study time for the pointer. The pointer will be rotated over the dial indicator. That will take some time. While we are unloading, while we are loading it, immediately you don't unload. Once we unload it, we need to wait for some period of time. So what some people are doing, immediately they are load it, and within a fraction of the people are immediately unload it. So that will be affected to the machine as well. We will not get the proper results. Right? We have to wait for some period of time. Then only that load will be completely transferred. Now we will get the perfect impression over the workpiece, so that we need to wait for 10 minutes, 15 minutes and 20 minutes or 30 minutes. Is 30 minutes is for dwell time or study time. Here also 30 minutes is there. Here the 5 is there. So the stainless steel and this type of the stainless steel and carbon steel, iron, martensite steel and diamond also we can able to perform. Suppose if you want to determine the hardness value of the diamond, then what kind of the machine can I choose? Because out of three, which machine is suitable for the diamond type of the materials? Because our aim is to determine the hardness value of the diamond. Then directly you can go for the Vickers test, so that you can get the correct results, correct hardness results of the diamond. Okay. Hope you understand about this is the theory. So will not take much time about theory. Now I will. So now we'll start from the procedure. Here we will look into the procedure how we need to conduct this experiment. Right? What are the steps we need to follow to complete the experiment? So this way we can call it a procedure. That now first I will show you the machine. Yes, this is we can call it as a Vickers machine, Vickers testing machine. Here we can able to see, here there will be the microscope at the head of the machine. Now we are providing the electronic microscope at the head of the machine itself. Here we have a red indication and green indication. Green indication it's a start, and red indication it indicates the stop the operation. Here we can able to see the indenter holder. Most of the time this indenter and indenter holder are fixed into the machine. That indenter is type of the indenter is most of the time it's a diamond, right? So that particular angle we are choosing the diamond indenter. Now we are fixing into the machine. Most of the time it is fixed. Here at that beside of this indenter holder, here we can able to see other knobs. This knob is a microscopic knob. Here this knob has a lens, focusing lens, knob and focusing lens it is. Once our work done, that is what we can, once we are applying the major load on the workpiece, up to the dwell time or up to the study time, you just push back to this, or you can tilt back to this pointer. Once you tilt back, this knob will be come forward, and we are pushing this back, so this knob will be come forward, and that knob itself it has a focusing lens. That lens will be focus the workpiece, that capture the image, then that will be sent into in the form of signal, that will be sent into the screen. Now you can able to see the image of the penetration or indentation, because this focusing knob is focus the image or focus the penetration. So the penetration is almost in the diamond shape, or it is look like in square shape. That will be focused by the focusing lens. Then that image will be appearing on the screen. By adjusting this screen, now you can determine their dimensions diagonally, D1 and D2, right? Okay, how we need to determine this I will tell in the next step, well, where the simulation we can able to discuss. Now yes, now I'm directly coming to the step one. Okay, so in step one, here we need to select the brass or aluminum. What you want, you can select it, right? Yes, here they are selecting the brass material. Suppose once we click on the button, now once again I will tell you the step one. The type of the indenter used diamond, So diamond indenter they are using. That also I will explain you. The indenter sometimes made by the hardened steel, sometimes made by the diamond materials. Sometimes they are hard carbide materials are made by that. Indenters are made by the much harder materials. Now we are using the diamond indenter, the so cone indenter or cone indenter with a square based pyramid shape. That I will tell you now. That square based pyramid shape indenter we are using, so that we as we can see the image here. Here there are three different types of the indenters are available. This is a like this. The indenter will be like this. Now we are choosing this type of the indenter. So fix into the indenter holder. That is the first step. Then we need to select the material. Now we are for example the geometries we are selecting the brass. Once we are click on the bar brass, or once we are selecting the bar, we need to brass. Then we need to take the load of about 20 kg. Right now, this is the first step. And the second step, now we need to understand the select the specimen is applied on the supporting table, and the light is adjusted by the rotating and wheel. Simple case. So second step, you know very well. Once we select the material, now based on that material, we need to select all the parameters like loads, indenter, minor load, major load, everything we need to select. Then once everything is we are selecting, now we need to perform the experiment. Then we can keep the workpiece upon the anvil. Now we are placing the brass sample over the anvil. Then you need to rotate this. Yes, one to with the hand lever, you need to rotate this, or you need to turn clockwise direction. This three will be rise up, and workpiece. There will be the contact between the workpiece and the engine change. Then now with the help of this side, this is the load unit. With the help of this load unit, you know you can adjust the loads for 20 kg. Then you can start the start button. So once you set this load, then you can start the start button. Now the load is applied over the material, right? Then third step here you can able to see the how to apply it. That is will be a third step. The load to be applied on the specimen is set by the adjusting knob. Here we have an adjusting knob. Here we are selecting the 30 kg force or 20 kg force. That is depending upon the type of the materials. Once we done this process, now we can stop the button. Now the applied load will be applied on the workpiece, right? Now then step 4, now we need to wait for the dwell time. The time up to which the load has to be applied for the specimen is adjusted. The load is applied for the period of 10 to 15 minutes. Once you start this button, you wait for 10 to 15 minutes, sometimes or not minutes, 10 to 15 seconds, or sometimes 30 seconds you need to wait. Some people what they are doing, immediately they are starting the or they are pressing the start button. Don't do like that. Once you switch on this start button, you have to wait for as per the material 15 seconds, 20 seconds, or 30 seconds. Up to 30 seconds only you can stop the button, or you can press the stop button. Once you press the stop button, now it stop, right? This is what we can adjusting the time also, based on the type of the material. If you want to if you need to set 15, you can set the 15 seconds, or if you want 20, you can set the 20, or else it is 30, you can set the 30. Okay, now then step 5 is once apply the selected load by pressing the green button for 2 to 3 seconds until the red light is glow, right? After that, not 2 to seconds, after the 10 or 15 seconds, what we are fixing the dwell time. After the dwell time only, this red dot will be blowing, start blowing. Once it start blowing, now applied load will be completely applied. Now hence we get the impression over the workpiece, the perfect impression over the workpiece. Then we need to determine the diameter of the indentation. Hence here we can able to see this portion. Now I have magnified here. Here there will be the screen. Now once our work is done, applied process will be done. Now just tilt back this knob. Once you tilt back this indenter holder, the focusing knob will be come in front. Once it is come in front, this will be focusing the workpiece, particularly indentation. That would be focusing the indentation. That focused indentation shape will be appearing over the screen. Now with the help of screw gauge, or with the help of the micrometer, now we can adjust the image in properly. That will be cover the number of lines. These are the millimeter lines. You have to set properly that image should be, we make ensure that the image should be properly touches the both the ends are properly in the lines. Either you can start from here, you can start from here, anywhere you can start it, but one end is perfectly touches to the first line, whereas other end should be perfectly touches to the next line, wherever it is, right? Or if suppose you are touching this, that first edge will be touching this first line, like that you should make ensure. Just let touches to the next, that other side end will be where it is touches. If it is touches to this line or in between this, suppose that first end will be the touches to this line and second end will be touches to this line, the how many line it would cover, that workpiece, how many lines that workpiece will be covered from here to here, 1 2 3 4. Okay, the 4 millimeters it is. Now the 4 line will be covering that 4 millimeters. The diameter of the indentation will be 4 mm. Suppose in between these here, so in between these you can approximately take 1 2 3 or 3.5. The small d will equal to 3.5. That I will show in the next step. Any doubts? Any doubts? Any doubts you can ask. No problem. So mute Malappa. Now coming to the next step. So the step 6 is now, yes, that's what. Once the load is load applied and everything will be done, now then you can click on the screw meter, because here we can able to see the workpiece. Because this knob is one front, this will focusing the image. That image will be appearing over the screen. Now that screen I will show here. So here we can able to see the screen. Now you can, with the help of this screw gauge micrometer or screw gauge, you can rotate the screw gauge. You can adjust the workpiece. That should be properly, one end should be properly touches to the first line. That other end here we can able to see this and leave it this end where it reaches and where it shows. That is least bother. That will not our aim is to make ensure that this point will be properly touches to this, right? Then you can count from here too. And what about this end? This end, suppose this end will be touches here. Now you can count from here to here. If it's beyond this, you can count also. This will be the half. So this is 3 and this is 3.5, like this, right? Okay. This is the horizontally. Now we are one diagonal. Now if it is 3.5, you can note d1 is equal to 3.5, right? Then this is horizontal. Then you can, the next time, now you can adjust the knobs. This portion now it is a look like a horizontal. Now you can turn this. The screen will be in vertical. Once is vertical, this will be also vertical. Then you can take down vertical lines. Now it is horizontal or it is vertical. Now think it is, these are the vertical, the lines are in the vertical position. Once you can turn like this, this will be the horizontal. Hence this is the d1 vertically. Whenever we are taking the values from this vertically, this is d1, this is the d1. When you are turning this in this position, the reverse position, now again we can adjust the knob to get the values. That will be the d2, that is horizontal. Vertically, okay, this is this, now it is in horizontal position. Now we can turn this, this will be the vertical position. In this vertical position we need to take the how many millimeters that image will be covered. Now this is right, now it is in the horizontal in manner. Now we can collect the diameter millimeters, how many millimeters that workpiece will cover. Once you done this, you can turn this vertically. Once again you can read the values. That will be the d1 and d2. Okay, Right. Now we'll directly go through the simulation so that we can understand better. Am I audible? Hello?
Yes, sir.
Okay. Now I will show you the simulation, how it works, so that you can understand better. Okay. I will start once again. Already I have made this. Hmm. So Vickers Hardness Test, but directly we can go for the simulation. Yes. Now let's start the simulation. Here the person who is conducting the experiment. So this is about our image of machine. Now let's start the simulation. Yes. Step 1. The type of the indenter used as a diamond indenter or cone type of indenter and square base pyramid. Now you can select any one, aluminum, brass or mastic. Now suppose I wanted to select the aluminum. Yes, now I'm selecting the aluminum. So I hope you can able to see this. Now I'm selecting the aluminum. There will be a shown the indication will be the red indication because it would select it now. So yes, the applied load will be indicated here, the 10 kg force. Once we got, once we select the aluminum, now this will be an indication red color. Now this means we are selecting the aluminum. Now the kgls also that will be show the kg 10 kg force. Now the next step. Yes, now we are selecting the aluminum. Now we are keeping upon the workpiece. Then we need to raise the pendulum. Yes, now I am raising the sorry, not pendulum, I am raising the lead screw or a screw with the help of the hand lever. Now the screw or anvil is raised up, that will be contact with the workpiece. Now we are making sure that workpiece and the indenter will be should be in close in contact. Yes, now this is second step. I hope you understand this. Now coming to the second next level, level 3 or step 3, the load to be applied on the specimen by set the adjusting the knob. Now we need to adjust the knob as per your aluminum. Aluminum already how much it shows? 10 kg or 20 kg it shows. Hmm? Yes. Now once we click on the button here, now it shows 10 kg force. For aluminum we need to apply the 10 kg force. Now this is 10 kg force we are selecting. This is the step 3. Now we will move on to the step 4. Yes. Step 4. Now we are applying the major load is around about 30 kg force. Now we need to wait for the dwell time. Dwell time is 10 to 15 seconds for the aluminum purpose. Now we can click the dwell time. Yes, the time starts now. Once we applied, we need to wait for 10 to 15 seconds. That also we are setting for 15 seconds we are setting, right? Yes. Now it's 30 seconds, right? Now coming to the next. Now after 30 seconds we need to unload it. That will show the next. Yes. Now you can start the button. After 30 seconds, now you can start the button because it is unload condition. Yes, now you are starting the button. Then go for the next. What will happen once we press the start button? Yes. Now once we after that 15 or 30 seconds, we need to unload it. After the unload, so we have to start button means that knob, that pointer will be back. This pointer will tilt back and the knob will come. Now the knob is focusing the workpiece. That focused workpiece we can able to see with the screen that I can show it here. See, here we can able to see the rhombus or print over the workpiece. Here we can able to see the print here. Now we need to determine the diameter of this. This is now, it is a vertical in this. This is in the form of vertical is that is diagonal length 1. Now we need to determine how much we will determine, how much it is. See, once you can click the button, press button here. Now it is, now this screw gauge is, by adjusting the screw gauge, now we will get the diagonal length, one diagonal length of the workpiece, that will be in the x direction. It is okay. In x direction, how much we will get here now? 0.362 mm. Note down, it is very very important. Now the diagonal length 1, the d1 is equal to 0.362 mm. Next, we need to determine the one more diagonal length, that is what, in y direction. This is the x direction we need to determine now. Now the y direction we need to determine. Yes, see, the whenever we are taking the y direction, this will be the horizontal lines, but look like this is the vertical, but line will be the horizontal here, right? Earlier it was in vertical in the form. Now these are in the form of horizontal lines. Now the here we have a workpiece. Again we need to set the workpiece. Already it is set. Now I have pressed it already. Now how much it is? Again it is in y direction also, 0.62 mm. Why it is showing same values? In x direction also, diameter of the diagonal length of the penetration is the same. In y direction also it is same. Anybody? Because diagonal length of the both of the sample will be the same. Why? Hmm? I'm audible. Hello? Say at least yes or no. If you say no, then I will. No, na. Because in the beginning class only I told, na, this rhombus is, once it is look like a square, right? Rhombus, whenever you look into the front or top view, it is look like a square. Once it is a square, all the sides are
Same.
all the sides are same. No doubt, all the sides are same. You can take vertically in x direction, you can take in y direction, in any direction you can take, the square will be the square. All the sides are equal. How much x value, that y value also same. Now we are finding the d1 and d2 value. Let's see what happens. Simple case. The specimen is aluminum. Applied load is 10 kg. The diagonal length, diagonal of the indentation in mm. D1 is also 0. D1 is 0.362 and D2 is also 0.362 because of the square pyramid it is. So the both the sides of the square pyramid will be the same. Hence that we will get the same value. Then we need to take the average of these D1 and D2. The average diagonal length of the specimen is equal to, again it is 0.6. Then Vickers Hardness Test. Here so we have a formula. So 0.819. So this is the constant value into F applied load divided by small d square. Yes, this is the constant value 0.819. So into F. F means applied force. Applied force will be the 10 kg force and divided by small d square. Small d is how much? Small d is 0.362. Just you can fill these two values. The simple formula it is the constant value 0.819 into F divided by small d square. F is applied load 10 kg force divided by small d is equal to 0.362. Simplify this, you will get Vickers hardness number is 141.48. I hope you understand. If you are not understanding, you can take it one more trial, right? Listen carefully. We will take one more trial. Simple case it is. Just now we are selecting the aluminum material. Then we need to establish the close contact between these two. Then we can go next. Now the next important step is to apply the applied load. Then you can set the load as per your required loads. Now we are setting the 10 kg but because of the aluminum we are selecting. Now once we are selecting the load, then we can go for the next. Now we need to wait for the dwell time 10 to 15 seconds. Whenever you press this button, now the time will begins. Just wait for the 15 seconds. Now we can go for the next. Now everything will be set. Now it is around about more than 30 seconds. We will wait for the 30 seconds. Right. Now you can go for the next process. After 30 seconds, now we can start. After 30 seconds, so that dwell time, everything will be done. Everything will be done means the entire 10 kg force is applied over the sample. Then the impression is also done. Then that indenter will be moves back. Then the focusing lens will be come front. Now this focusing lens will be focusing the workpiece of the indentation that the printed over the workpiece, that is we can call it indentation. That indentation is appears in the screen that we can able to see here. Once you can start the button, now the measuring of the dimension of the indentation will begins. Once you can press the button, yes, now what happens? Yes, here we can able to see the image of the indentation or penetration over the scale. Now we need to get the exact size, diagonal size of the indentation. Then we can use the microscopic view, the screw gauge micrometer. Now we are adjusting the with the help with adjusting the image in properly with over the scale by using the screw gauge micrometer. Now we will get the diagonal length which is in the x direction is 0.361. So again we need to take in a vertical manner. So again you can press the button. Now we will get the in y direction, the diagonal length will be also the same. Then the last thing you can make the average of d1 and d2. You will get the small d value. Then you can so the put the values in this formula. Then you can get the see that first trial we have been scored for 141.84. The second trial we will get the 141.87. The average value of the Vickers Hardness number is 141.68. Hope you understand. It's clear? Hello? It's clear now?
Yes, sir. It's clear.
Okay, thank you. So thank you very
Thank
much.
you.
Okay. So now okay. Tomorrow we will take the uh, tomorrow we will discuss the some quizzes and self-evaluation about this experiment. Also Brinil and Vickers Hardness Test. We will take the self-evaluation and quizzes to the beginning of the uh, class tomorrow. Okay, now I will wind up this meeting so that you can do the meeting. Just wait for I will take the attendance. Yes. Okay, now you can leave the meeting. Okay,
Thank you.
thank you very much. Thank you.